Hello and welcome to Sean White's Solar and Energy Storage Podcast. This week we're going to talk about the different lithium battery chemistries. There are so many of them, you hear people shout them out with TLAs, that's three-letter acronyms, such as LFP, NMC, NCA, LCO, LMO, LTO, and more. The goal here is by the end of this podcast, you should be able to remember the top three lithium battery technologies, which are LFP, NMC, and NCA. So we're going to say that over and over again, and we're going to get into it. I also recommend that you can go back and re-listen to this podcast if you start to forget. But plus, that would be boring just to go over three things constantly. So we're going to talk about a few things in between. However, let's start at the top and go through these different lithium-ion chemistries. And lithium-ion typically means a lithium metal oxide cathode and a graphite anode. So the cathode has the letter T in it, like positive. So that would be the positive pole of the battery. And the anode, second letter is N for negative. That's how to remember that. So let's start at the top. LFP. What does that stand for? That stands for lithium iron phosphate. And the reason that iron is F instead of I, instead of LIP, then we could call it a LIP battery, but nobody does. They call it an LFP, or sometimes LiFePO. We'll get into that. Those of you who have taken chemistry classes know that Fe is the symbol for iron. It comes from the word ferrous, not as in Ferris wheel or that guy that's really famous for podcasts, Tim Ferriss. It is Fe for ferrous for iron. So that's lithium iron phosphate, is otherwise known as LFP. Now, the next super popular type of lithium battery that we have out there, maybe the number one lithium car battery, is lithium nickel manganese cobalt oxide. In order to make a three-letter acronym out of that, we change that. We drop the lithium, we drop the oxide, and we just end up with nickel manganese cobalt, NMC. That's lithium nickel manganese cobalt oxide. For some reason, I remember that from that old rap band that used to play Aerosmith songs called Run DMC. So now we have Run NMC. Hey, whatever kind of crazy way you could remember things, the crazier the better. That's how your memory works for some crazy reason. And now for the third lithium technology that we're going to talk about here is called NCA. And that NCA stands for lithium nickel cobalt aluminum oxide. Tesla is famous for doing the NCA batteries, but they also do other kinds of batteries too. So NCA, lithium, nickel, cobalt, aluminum oxide. And so those were the three big ones. So let's see how your memory's working so far. LFP, what is that? That's right, lithium iron phosphate. Next one, NMC. By the way, once in a while you'll see it as NCM, but NMC, what does that stand for? They all start with lithium. That's lithium, nickel, manganese, cobalt, oxide. And now the third one is called NCA. And let's see how your memory is working now. What does NCA stand for? That's right again. Starts with lithium, then nickel, then cobalt, then aluminum, and then oxide. Let's get into a couple other ones that aren't as common, but we'll just mention them. There's LCO. That's for lithium cobalt oxide. That might be what's in your phone. There's LMO, that's lithium manganese oxide. And then there's LTO, which is lithium titanate oxide. Not too common. Also, you might hear in the news about lithium metal batteries. Lithium metal batteries have a lithium metal anode. So they don't have a graphite anode, they have the lithium in the anode. They might be the future of lithium batteries, but in the meantime, they're not as safe. They don't go through enough cycles to make it worth using them currently. But read the news, you'll hear about lithium metal batteries. And once again, that means the anode in that case is lithium metal. Instead of having a lithium metal oxide cathode, you have a lithium metal anode. Now, if we want to talk about what's the best specific energy, that's energy per weight of these batteries. And let's just talk about the top three now. Typically, the NCA batteries, that's the lithium nickel cobalt aluminum oxide batteries, NCA, is typically the best for specific energy. Some people will say energy density, but it's specific energy when you talk about energy per weight. Energy density is energy per volume. And so those NCA batteries, they're at the top of the list. And close by is the NMC batteries. That's the lithium, nickel, manganese, cobalt oxide batteries. NMC might be the most popular battery out there. And they have good specific energy, and we see those in a lot of cars. And now our third popular battery here, the voltage isn't as high with these lithium iron phosphate, these LFP batteries, but they're very stable and they don't require cobalt. So the other two, the NCA and the NMC, those Cs are for cobalt. Cobalt is typically mined in the Congo. There's problems with that. They say there's child labor mining cobalt, which isn't good for your company's reputation. Another thing, by the way, is NCA batteries use less cobalt than NMC batteries. However, there are different recipes, so you might see different information out there. Once again, specific energy is best for NCA, then close by is NMC, and the worst specific energy of these famous lithium-ion batteries is LFP. We usually say that the nominal voltage for a lithium-ion battery is 3.6 volts. Well, it's 3.6 volts for the NCA and the NMC batteries, but the lithium iron phosphate batteries are 3.2 volts nominal voltage. So let's look at some of the different things that are in these batteries. We typically will see lithium abbreviated as Li or just L. The letter for C on the periodic table, that's chemistry, is C for carbon. However, a lot of times you will see people using C for cobalt, as in NMC or NCA. Cobalt's full abbreviation is CO for cobalt. And once again, we have Fe, that's the symbol for iron. Manganese is super popular. That's in the NMC battery. And manganese, not rare at all, so it's not hard to come by. And the abbreviation for manganese is Mn. Then many of you probably know the abbreviation for aluminum, which is a very popular element, is Al for aluminum. That's in the NCA battery. So don't forget LFP, lithium iron phosphate, NMC, lithium nickel manganese cobalt oxide, and NCA, lithium nickel cobalt aluminum oxide. You might have heard in the news that Tesla is making a deal with cattle. It's not the cattle that increases horsepower, it's the cattle that's the Chinese battery company, abbreviated CATL. So these batteries that Tesla is making a deal with this huge battery company are lithium iron phosphate. However, historically, Tesla's been making batteries with Panasonic using the NCA battery. That's the lithium nickel cobalt aluminum oxide, rather than the CATL lithium iron phosphate battery. One of the other big popular battery companies is LG Chem. LG Chem is famous for the NMC battery. That's the lithium nickel manganese cobalt oxide battery. A lot of these LG Chem batteries go in cars, and they go into the LG Chem energy storage system. In fact, speaking with Tesla, they even do buy some LG Chem batteries. So let's go back to our top three again. We have lithium iron phosphate, that's LFP. And if you use the chemistry symbols, you've got LiFePO4. So there are people out there that call it LiFePO because it's LiFePO when you read it, LiFePO, instead of LFP or lithium iron phosphate. For the NMC battery, that's lithium nickel manganese cobalt oxide, which sometimes you see as NCM. If you looked at the full chemistry symbols, it's Li for lithium, Ni for nickel, Mn for manganese, Co for cobalt, and O2 for oxide. That doesn't spell anything fancy like LiFePO, so we just call that NMC. Also, for the NCA, that's the lithium nickel cobalt aluminum oxide. That's Li for lithium, Ni for nickel, Co for cobalt, Al for aluminum, and O2 for oxide. And by the way, if you're starting to feel guilty about child labor in the Congo, you can donate to unicef.org/dr-congo/en. In the Congo, it's kind of a sad choice. You can have child labor or starving children. And you likely have some cobalt in your pocket, by the way. It's that thing that you watch movies on and take pictures. Some people call it a phone. So one of the things that they're trying to do is figure out how to use less cobalt. They change the recipe, they change the ratios, or they might be switching off to LFP or some kind of fancy lithium metal battery in the future. So speaking of these ratios, the NMC battery, that's the lithium nickel manganese cobalt oxide, a lot of times they have a ratio of 1 to 1 to 1. But they've been changing that and playing with that ratio so they can use less cobalt. So another popular ratio is 5 to 3 to 2. That would be 5 parts nickel, 3 parts cobalt, and 2 parts manganese. One thing about the NCA, that's the lithium nickel cobalt aluminum oxide, is it takes less cobalt than the NMC battery in general. And they're changing that recipe. So the earlier Teslas would take 11 kilograms of cobalt per vehicle. These days, they use about 4.5 kilograms of cobalt per vehicle. So some other benefits with the LFP, that's the lithium iron phosphate batteries, besides having no cobalt in them, is they can be more thermally stable. They're more tolerant to overcharging. In fact, you can charge them with what you charge a 12-volt car battery with. However, it's not as good for the batteries to do it that way, and the batteries will wear out a lot sooner, because if you put 4 3.2-volt lithium iron phosphate batteries in series, that gives you 12.8 volts. Car batteries typically, when you're driving down the road, are charging at 14.4 volts. So it won't make your battery explode to charge it that way if you swapped out lithium iron phosphate for a lead acid battery. However, leaving it at that high charge for a prolonged period of time, such as a road trip, would wreck your battery. And if you tried to do something like that with an NMC or an NCA battery, something could explode. That's why with all lithium-ion batteries, you should control the charge with a BMS. That stands for a battery management system. And you pretty much have to do that. That's why these lithium batteries come with electronics built into the battery. It's not some kind of old-fashioned lead-acid battery. It's got electronics in it. There's like DC to DC conversion and when not to overcharge it. You can trickle charge a lead-acid battery, but that would damage, or even worse, for a lithium battery. So no trickle charging these lithium batteries. Okay, are you ready for your test? First of all, what are the 3-letter acronyms for the 3 main types of lithium-ion batteries? That's right, we have LFP, NMC, and NCA. Now, what does LFP stand for? That's right, it's lithium iron phosphate. Next, what does NMC stand for? That's right, it's lithium, nickel, manganese, cobalt, oxide. And the last one, what is that? That's NCA, and that stands for lithium, nickel, cobalt, aluminum oxide. So remember, come back to this podcast as much as you want to memorize these different lithium chemistries. It's very important to know these things. It will make you look smart. Thanks for listening to Sean White's Solar and Energy Storage Podcast. To learn more about Sean White, energy storage, solar, or to have consulting, go to solarsean.com. Have a great day.